Okay, so we've just learned about the angles of elevation and depression with quite straightforward problems with just right angle triangles, like a single right angle triangle. This problem here has two different angles of elevation and depression that we're looking at, and we're going to have to draw the diagram ourselves. So let's go and use what we've learned to apply to this problem. So two buildings, 50 meters apart. Building A is 110 meters high, and B is 40 meters high. So that's the information we need to draw the diagram. I'm going to start with building A. It doesn't matter too much if this drawing is not to scale. I'm exaggerating some of the distances here just so that it's easier to draw the triangles afterwards. So that's the bottom of A to the top of B, and it wants the angle of elevation, which is this angle in here. So that's for part A. We'll call that angle A. Then for angle B, find the angle of depression from the top of A to the bottom of B. Okay, so that's coming off this normal here. That's angle B. Lastly, find the angle of depression from the top of B to the bottom of A. It's going from this normal here, finding this angle. Call it C. Alright, so we're ready to start. Just going to move these in there so it's clear. Okay, so the first one we're finding is A. So if we look at A, we've got this triangle here to focus on. And we've got two sides. For this triangle, we'd label that as opposite and adjacent. So that's going to be using TOA. So this is for part A. Equals opposite over adjacent. A is the inverse tan of that ratio. And it doesn't specify what level of accuracy, so I'm going to do to the nearest whole number. So that's 39 degrees. Now for B, rubbing those out now because for B potentially have different opposites and hypotenuse, etc. So for B, we've got the angle of elevation there. Now we know that this height here is 110, or another way of writing it is that this is the same as B using alternate angles. So actually the triangle that we're going to focus on is this triangle here, which incorporates B in the corner. So that's using an alternate angles rule. So from that we have the opposite side again, and we have the adjacent side. So we're going to use TOA again. So we're going to do inverse tan of that now. So 66, nearest whole number. Alright, now lastly, we've got to find C. Now C is actually going to be a bit easier than the other ones, because C has a relationship with A on the alternate angles rule. So for part C, it's actually the angle C is equal to A because alternate angles, and so therefore C is equal to 39.